So welcome everyone to KCD Taipei today. I'm K0rdent from Kubernetes, and today I'm excited to share how we're solving one of the biggest challenges in modern cloud infrastructure, which is managing Kubernetes at scale. So today we'll be diving into what we call k0rdent. So it's a multi-cluster architecture platform that's developed. It's open source. And it's changing the game for organizations running dozens or even hundreds of Kubernetes clusters. Okay. Yeah, so let's start with reality check. So how many of you are managing more than one Kubernetes cluster? Anyone more than one? Okay, I see some of them. Okay, anyone more than 10? Okay, yeah, there are people more than 10. So anyone more than 20? Okay, still people managing more than 20 clusters. So as you can see, we're not alone in this challenge. And the reality is that Kubernetes has become successful. That we're now dealing with a cluster sprawl and unprecedented scale. So when we talk about Kubernetes, organization running Kubernetes at scale, we hear that there are same pain points over and over again. And let's walk you through some of the pain points that we observe. So first, you have multiple clusters scattered around different regions and cloud providers. So you may have one in AWS, one in Azure, one in GCP, and one in your private cloud. And each cluster might have a different configuration. And maybe your dev cluster has different version than your production one, as maybe you upgrade your dev cluster more frequently. And therefore, manual provisioning become a full-time job. So you have to do a lot of stuff to do upgrades, to deploy applications on them. And we don't even mention the compliance and governance stuff here. So maybe you have certain security standards that you have to meet to provide to a customer. So that's when the real headache begins. So how are teams tackling with Kubernetes today? So maybe they start with manual kube control and Helm deployments, like everyone is familiar with it. And it does work great. It works great for a few customers, but it doesn't scale very well. As if you use kube control, you have multiple clusters, you maybe have to switch between config a lot. If you use Helm, you also have to switch between configs, and you have different volumes file for each cluster. And for the next step, people build custom scripts and CI/CD pipelines. Like they use infrastructure as a code to maintain their clusters. But now you're maintaining your infrastructure and the code itself. And of course, there are some cloud-specific tools like maybe use EKS, use GKE, use AKS consoles, but they only work for a single cloud. So if you use EKS, you're basically locked into AWS. And if you want to do multi-cloud, you could not use these tools to manage your clusters. So why they don't work? So the fundamental problem is that these approaches doesn't give you a unified control plane. So everything is scattered across different places. So you probably end up with configuration drift. So your staging cluster might slowly diverge from your production cluster. So things happens in production cluster might not occur in your staging, making it hard to solve issues that happens. And also you have limited visibility. So when something goes wrong in one cluster, you have to be jumping across different tools and dashboards to try to piece together what went wrong. Yeah, so these are the current challenges that we hear a lot of different Kubernetes operators face. So before we dive into k0rdent itself, so I will tell you about some context about how it fits in the broader ecosystem. So at Norantis, we basically build a family of open source projects that work together. We call it the K0 family. So it's a layered approach for Kubernetes management. So it consists of 3 major projects. So first we start with k0s, which is Kubernetes distribution, CNCF certified, which targets single Kubernetes cluster install. So if you need a single reliable cluster, that's your data plane. So next is k0s Multron. So it's a cluster API provider that's installed k0s on provided infrastructure. So you can use it to spawn multiple Kubernetes clusters with cluster API to make them manageable. And I won't talk about too much about these 2 projects today. I have a talk last year in KCD about these 2 projects. So if you're interested, there's a recording online in our community group YouTube channel. Yeah, and last is our topic today, which is k0rdent, which utilize the k0s Multron to manage a fleet of clusters. And other than the cluster, it also is able to manage the application that's you have to deploy inside of each child cluster. So each layer basically builds on one below. Yeah. So next, let's dive into today's main topic, which is k0rdent. So what it is, it's basically a multi-cluster Kubernetes control plane. So think of it as a mothership that's managed all your child clusters. So the deployment of it is very simple. So by using Helm, you can install it with a single command line. And what makes it very special is everything related to it is basically template driven. From spawning new cluster to deploying application into those child cluster, or configuring the cluster configuration, everything is template driven. And all this stuff is built on the k0s and k0s Multron, which I talked earlier. So basically, we start with k0s as the foundation, which is solid Kubernetes distribution. We add k0s Multron on top for cluster management capabilities with cluster API, so we can declaratively provision Kubernetes cluster. And last, k0rdent orchestrate everything from the top, allowing multi-cluster declarative provisioning. So each layer adds more capability without sacrificing the simplicity and the reliability of the layer below. So k0rdent follows a separation of different 3 main components. So we have KCM, which is, we call it k0rdent cluster management. It handles the cluster lifecycle. KSM is the k0rdent state manager, which handles the application you would like to deploy onto your child cluster. And we have KOF, which is k0rdent observability and FinOps, which give you observability stuff and cost insights. So the third component, KOF, is optional. So if you don't need or you have your own monitoring stack, you can like ditch it and use your own stuff. And I will talk about each component in the later slides. So first, let's look at the overview of the architecture. So we can see in the left part, we have the cluster and state management, and the bottom right is the cloud infrastructure providers where you spawn your child cluster. And the top right switch mostly about your child cluster definition. So basically everything on the definition will be translated into what you will see on your child cluster. We also utilize there's an open source project called Sabotage Controller Agent for application delivery. So all the components inside is open source, and you can make modification if you want. So let's first start with the cluster management. So we call it KCD as abbreviation. So basically, it's a higher level of abstraction of cluster API. Anyone here are familiar with cluster API or use it in production? Okay, so everyone here is using like cloud-specific tools like GCP stuff, or how do you deploy your Kubernetes clusters? Oh, sorry. Okay, cool. Okay, anyone has different method? Okay, yeah. So I will shortly talk about cluster API. So it's basically a Kubernetes upstream project that's able for you to use a single Kubernetes cluster with CRDs to deploy other Kubernetes clusters. So we made a wrapper on it to make it simpler for people to use. So and by using it, you basically can create or adopt. So if you have cluster that is not using cluster API today, you can basically adopt it into the KCM. So it supports most of the public cloud providers and private cloud or your virtualization platform if you use it in your company. If it's not supported, there's a method to allow you to add your own provider that is not officially supported. And what you basically need is Helm chart repo, which can be on registry or GitHub to add your custom provider. So next we have KSM. So KSM handles the application layer. So it's used what we call service template, which is one of the CRDs that we have to manage the application lifecycle across multiple clusters. So you can also chain multiple servers together to allow complex deployments, and it does validate upgrades before applying them. So for every upgrade, it will be validated. So to ensure that the application is running properly. So as we talked about, we leverage a research project called Sabotage Under the Hood, which and we provide a catalog of pre-built service templates to get you started quickly. And we have a web page called k0rdent catalog, which is open source catalog for service templates. And currently there's already a lot of different service on it. So you can just install those templates with a single Helm command, which I will demo later. So you can basically use it from scratch. And last is KOF, which is the components that provides observability and FinOps stuff. So KOF brings together metrics, logging, and cost management in one place. So you will have a single UI that you can interact on to view metrics and logging on your web page. So it basically collects metrics from various sources from your child cluster and aggregate it into a single control plane. Well, it also has a feature to enable you to calculate your costs using open costs. And it provides a unified control plane for managing Kubernetes cluster at scale. So everything you want to see your metrics, your log, your cost, how your Kubernetes cluster is running, how the component lifecycle is doing will be on the same place. And it also helps ensure compliance with organizational policy. So we have built-in audit trails, RBAC, and regulatory reporting. So if you're working on customer that have stricter policies, like maybe in banking industry or their company located in European Union, they may have very strict policy on their data or access control. Those are all built into KOF. So from a higher level perspective, so it contains 3 layers. So we have, in the lower part, we have the collection layer where all the statistics, the metrics, and events are gathered. And on top of it, we have a region layer, which includes storage to keep track of those metrics and logs. And at the management layer, we collect data from each region. So each region may have multiple child cluster, and then we centralize the metric into a single control plane that you can interact through the UI. So it will be easier for you to view how our cluster is running. Okay, so this graph may be hard to read right now. So basically, it's illustrating the lower level of k0rdent KOF, which show how data is flowing across multiple clouds. Okay, still hard to read as the text is pretty small. So on the left side is basically the child cluster part. We have 3 clusters, so across AWS and Azure. And in each cluster, we have a hotel connector, which collect logs from the application and the system itself. And we utilize OpenCost on each cluster to collect the cost metrics. And each region also have a dedicated storage which contains, if you want to access the metrics on those cluster only, there's a Grafana dashboard for each region. But a better way is to view it in the management cluster, which we have the mothership storage, which will collect all the metrics from every region. So you can view our metrics from a single UI. And it also includes long-term storage, so you can configure it to have data maybe dating back a year or 2 based on your company policy. Okay, so in previous slides, we talked about everything is template-driven in k0rdent. So why did we choose to use the templating system? So it's because template system is very Kubernetes native. So if you're using Kubernetes, you have been using a lot of template system before, like Helm, Customize, they're all template system. So it makes everything reusable and composable. So you can build it once, write your code once, use it everywhere, only modifying the values that you want to change. Yeah, so those stuff can be pre-tested or validated, so everything you deploy will just work. So by using the template system extensively, we can give you flexibility to customize different platforms without the need to write many new codes. So it provides more reusability and other points mentioned in this slide. Okay, so we have a lot of templates in k0rdent. So first we start with cluster templates. So cluster templates are basically Helm charts that defines how a child cluster is going to be created. So if you want to develop your own cluster template, you can start with plain manifest and then convert it into a Helm chart. That's when all the functionality is verified. We also have provide built-in templates which cover most common scenarios, which I will demo later in the demo session. Next, we have provider templates. So provider templates defines and configure the cloud API providers. So it handles how cloud-specific stuff is done and transferred to the cloud API providers. And the most important part in different cloud providers is credential transferring. So it may be very, very unique between each cloud platform that you'll be using. And if you have your own cloud platform, we also provide the ability to use Go templates or Lua to assemble secret objects. So you can transfer it to the child cluster as those credential transferring is maybe very unique. So next is service template. So service template is basically referred in cluster deployments, where when you want to deploy that service in a cluster. So a service template itself describes how your application is installed. So basically, it's a definition of Helm chart values and the Helm chart you want to use to deploy your application. And by leveraging project samples, we can ensure those applications is deployed correctly into your child cluster. So next, we can take a look about how k0rdent itself is installed on your management cluster. So in the installation, it's very simple. Basically, one Helm install command line, and the Helm install will install only 3 components. So as you can see, it's marked by the yellow parts. So we have the controller manager, server manager, and Flux. And the controller manager will create CRDs with Helm release, and Flux will start reconciling all those Helm release to install all other components that is needed in deployment, such as K0rdent, Motron, the cloud API providers, and project samples. So I won't demo the installation in the demo course, but we can take a look at what components are installed. So next we can look at the roadmap that we are going to develop for this project. So first, the core team will be working on adding additional modularity. So different companies may have different requirements, so we would like to make it more modular for you for it to suit your environment. We also be expected to add more out-of-tree providers, so providers that are custom and not included in the basic cloud API providers. And next, we will be extending the application catalog, which includes the service template that you can use to install the service into your child cluster. Okay, so before the demo, I would like to talk about one of the use case that we have, which is a company called Nabu. So you might not be familiar with this company, as it's a European company, and it is a company that's providing AI cloud to their customers, which they have a lot. So they are dealing with a serious scale. And of course, as they are a European company, they need to ensure that what they provide complies with the EU data challenges. So they have a lot of regularity around how their data is handled. They also need high security with isolated cluster. So instead of having all the customers in one Kubernetes cluster, they will have to use each customer with at least one isolated cluster for their needs. As they are providing AI cloud, they also have to manage all the NVIDIA graphics stuff, the operators, which will cause lots of pain points when spawning new clusters. So how k0rdent solve the problem? So it basically gives a unified control plane for all their shard cluster, which they have a couple of them. And they have already pre-modded templates, which they can use to deploy a new child cluster very fast and very consistent, which complies with the compliance that they would like to have. And we also include the FinOps tool, which let them be able to manage all their cluster in one place and maintain performance of their AI cloud. Yeah, so basically it's kept their security isolation without lots of operational overhead to manage lots of Kubernetes clusters. So the result is they went from chaos to control. So when onboarding a new customer, basically they just modify some of the values in their current templates, and then to apply templates, the cluster will spawn by k0rdent Moltron, and then all application will be ensured by the KSM and deployed on the child clusters. So after using k0rdent Moltron, they can rapidly onboard new customers and keep them security isolated. Yeah. So in the next part, I will give a short demo for how k0rdent in action. So I'll demonstrate basically how we can deploy applications using service template on one cluster or across multiple clusters. So in the demo, I'll be using a simple architecture, which I have the mothership cluster deployed using k0rdent, which we have two child clusters on OpenStack, which is in different data center, one in EU, one in US. So let me start with the demo. Is the text large enough for everyone to see? Okay. Oh, it's hard to type with one hand taking the mic. So everything in k0rdent is managed with templates. So we basically have three main templates. We have the provider template, the cluster template, and the service template. So if we look at all those CRDs, we have provider templates, which is our cluster API providers. We have basically most of the built-in ones with a lot of public cloud, or you can use private clouds such as OpenStack or vSphere. And for cluster templates, it's basically how you can spawn clusters on each provider. So like in public cloud provider, there may be different ways to spawn a single cluster. So for example, in AWS, you can use EKS to spawn a cluster, or you can use standalone VMs to deploy your cluster. So we have the template that provided for all those scenarios. Well, service template, we have some of the built-in ones, such as Cert Manager and other different applications. So later I'll show how we can find the application you want on the catalog. So on the next part, next step, I would like to demonstrate how we can. So I will demonstrate. Currently, I have two cluster deployed. So if we look at okay, so we have two cluster deployed, one in the U cloud, one in the US cloud, and currently all of it is in ready state. So if we look at how they are deployed, I have the cluster template here. So if you have worked with Cluster API before, they may be very familiar with it because it's a Cluster API template that we only modify some of the modules of it. So basically, we will refer the credentials that we need to access the cloud and we want to deploy our Kubernetes clusters on, and the number of workers and how the workers flavor is, and the network of the worker, the capacity and stuff, and other cloud-specific configuration. So next I'll demonstrate how we can deploy application on a single cluster. Okay. So here I'll deploy Search Manager. So as I already assumed, we already have the Search Manager service template on installed. So basically, we would like to patch the cluster deployment object to reference the Search Manager service template. So if we look at the piece we like to patch, so basically we will have to include the service template, the name of the service you want to deploy, the namespace, and the values you like to change for the template itself. So, yeah, run it. Okay, so currently we are in the EU cloud. Let's see. Okay, you can see the Search Manager is installed here. But if you look at the US cloud, I haven't installed it. I haven't patched the reference the service template in the cluster deployment, so the Search Manager isn't installed in US cloud. So next, I'll demonstrate how we can deploy application onto multiple clusters if we want. So, okay. So in this demonstration, I'll install SDO on both clusters. So first, I'll install the service template for SDO, which is included in the catalog. So let's see. Okay, so we have the application catalog. Where's SDO? Okay, so we have SDO in it. So basically, we just install the service template with Helm. Okay. We'll start the installation. Okay, so if we look at the service template here, you can see the SDO service template is being installed, and KSM will validate if the template is large or not. So take a look, and now, yeah, they are all validated. So next, I'll apply the config file. Okay, so to deploy application into multi-cluster, we'll use a multi-cluster service, which we can specify which cluster we would like to deploy on it with a cluster selector. So we will match a cluster with label group demo, and we will install these services, and we didn't want to modify the values of those services. So, just apply them. So it should be installed in the US cluster right now, but in the EU cluster, if you look at the YAML file, we didn't have the demo label, so it will not be installed for now. So let's take a look at the US cluster. Let's give it a refresh. Take. Oh. Okay, so the namespace is created. So yeah, the pod starts spawning. So let me add the label to the EU cluster also. Okay, so now we should have the label for demo. Yep. Okay. Yeah, you can see they are installed. And, okay. Yeah, so it will start installing on the new cluster. Yeah, so this is all about the demo today. And so I'm going to conclude my talk for today. So if you have any questions, feel free to ask me. I think we have only 1 minute left, so I will be around here. So if you have any question, you can ask me. And if you have anything you still want to know, I have a link for all the projects that we have. They are all open source, so feel free to read the code and make contribution. Yeah, thank you, Ron.
Thank you 那我们再次谢谢郭靖。